deductive reasoning might look like. We have two different forms that we usually use in geometry of deductive reasoning. One of them, and again, reasoning deductive is using logical steps based on a fact to reach a conclusion. Many times we use if-then statements. Okay, so we talked about if-then statements in previous examples, and what if-then statements do is they give us a law to go by so that we can reach a conclusion. For example, this first one, if you are tall, then you are a good basketball player. This is something someone has come up with, okay, and their law is that if you're tall, then you're going to be a good basketball player. The hypothesis is the if, the conclusion is the then. If you're 16, then you can drive, and if you can drive, then you have a car. So again, this is another law or rule that someone came up with. If you were 16, then you could drive, and if you could drive, then you have a car. Okay, that first example, notice, was a single conditional statement. It just had an if and a then. And here are two more examples of those. And that when we use those, that's called the law of detachment, using a single if-then statement to draw conclusions. So here's one. If you are in California, then you are in the United States. So the rule is, if you're in California, the conclusion you can draw from anyone being in California is that they're in the United States. Okay. Here's our second example. If you buy a stamp, then you can mail a letter. So the rule is if you buy a stamp, then you will be able to mail a letter. Now, to reach a conclusion with the law of detachment, the given information has to come from the if part. Okay, so in order to reach a conclusion with either of these rules, any information they give us past this would have to come from the if part. So to reach a conclusion with number one, they would have to say something about someone being in California, and then our conclusion would be they're in the United States. Okay, notice that them saying that, say, for example, John is in California, we use our rule right here. If someone's in California, they're in the United States. So we could say John is in the United States. We cannot go back the other directions. If they said John is in the United States, notice we cannot go backwards and conclude that he is in California. Same with our second example. To make a conclusion, we would have to know about someone buying a stamp. Our rule is if you buy a stamp, our automatic conclusion is that they can mail a letter. So let's say Tammy bought a stamp. Well, then we know Tammy can mail a letter. On the other hand, if we said Tammy mailed a letter, we don't automatically know that she bought a stamp. There are other ways, like maybe someone gave her a stamp. Okay, so that is how the law of detachment works, the basics of it. Let's do some examples. Let's say whether each of these conjectures is true or false. So notice we have a single if-then statement in our first example. If 4x minus 5 equals 3, then we know x is 2. The next thing we know is that x equals 2. This is our second statement. This is our given information. So the first one is our law that we're using. The second one is just some information they gave us. Okay, the x was 2. This person's conjecture, sorry, I keep going off of my slide. This person's conjecture was that 4x minus 5 had to equal 3. Okay, well, if we use the law that they gave us, we can't do that. Okay, the law of detachment says we have to come from the if part. Okay, so if x equals 2, we cannot use this conjecture. Here we would have to say that this one is false. And the reason for that is it came from the wrong part of our statement. Our given information, our second given information, has to come from the if part in order to make a conclusion. Let's try the next one. Given that 3x minus 4 is 11, then x equals 5. That's our rule. That's our law of detachment. That's our rule. Here is our next given information. 3x minus 4 is 11. And their conjecture was that x would have to be 5. That one works. Okay, this one is true, and it's because our second piece of given information came from the if portion of the statement. So this one is true. Up next, if you're in California, then you are in the United States. That's our rule. Okay. Our given information after that is that you are in California. The person's conjecture was that you were in the United States. Okay, did that follow the rule? Yes, it did. Our given information came from the if part, so we could make a conclusion, and our conclusion should be the then part of the statement, which it was. So this one is true. Okay, here's our final example. If you buy a stamp, then you can mail a letter. That's our rule we're using. The second piece of given information, you mail the letter. And their conjecture was that you bought a stamp. Is that true or false? Did they get it right? Hopefully you said false. The reason for that is to make a conclusion, our information has to come from the if part. That's the only thing we have a rule for. You mailing a letter does not mean that you bought a stamp. Lots of other things could have happened. We can only talk about the rule we're given, and it has to flow in the correct direction. We have to have information about the if part. If they had said, you bought a stamp, we could conclude that you can mail a letter. We cannot go back the other direction. So let's try a couple of these. By the law of detachment, is this conjecture true or false? We are given that if a child cleans their room, that child can go to the movies. Jimmy cleaned his room. Can we make a conclusion? Well, this person did. They conjectured that Jimmy can go to the movies. So let's take a look. Was that true or false? Did they get it right? Our rule was if someone cleans their room, that person can go to the movies. The next piece of given information was that Jimmy cleaned his room. Did it come from the if part? Yes, it did. Cleaning your room was the if part. So we automatically know if you clean your room, you get to go to the movies. So Jimmy gets to go to the movies. This person got it right. This is true. Right, here is another example. If 9x minus 9 equals 45, then x is 6. There's our rule. The piece of information we were given is that x is equal to 6. The conjecture is that 9x minus 9 is 45. Okay, now these are a bit more confusing, but again, follow the laws that we have. Okay, we have the law. If 9x minus 9 is 45, then we can conclude x is 6. Our second piece of given information has to come from the if part. Did it come from the if part? No, it did not. So we cannot make that conjecture. This person is false. Their given information did not come from the right part of the statement. All right, let's determine if this conjecture is true by the law of detachment. We are given, here's our rule, if the length and width of a rectangle are 8 inches and 4 inches, then the area of the rectangle is 32 square inches. The length and width of the rectangle are 8 inches and 4 inches. So here's our rule. As long as we have a rectangle with measurements 8 inches and 4 inches, then we know its area will be 32 square inches. Our piece of given information is that the length and width of a rectangle is 8 and 4 inches. They made the conjecture that that means the area would be 32 square inches. Did they get it right? In order for that to happen, the given information we have there has to be from the if part. Is it from the if part? Yes, it is. That was exactly our if part. Okay, so our conclusion would be the then. The area of the rectangle is 32 square inches. So this person did this exactly right. Okay, this one is true. Let's take a look at this example. If the length and width of a rectangle are 8 and 4 inches, then the area of the rectangle is 32 square inches. Again, that's our law that we're using here. The second piece of information is that the area of this rectangle is 32 square inches, and this person conjectured that the length and width would be 8 and 4. Did they get it right? Okay, remember, in order to make a conjecture, our given information here in the second line has to be from the if part. And notice it's not. It's from the then part. They're saying the area of a rectangle is 32. That does not automatically mean that its length and width are 8 and 4. If you think about it, we can actually logically think this one out and say it's wrong. What if we had a rectangle that had an area of 32 square inches? Well, what are some other dimensions? It doesn't have to be 8 by 4. It could be 16 by 2. 16 by 2 rectangle, 16 times 2 is 32. Okay, so we cannot automatically say when we have an area of a rectangle that's 32 square inches, it doesn't automatically mean its length and width are 8 and 4. It could be something else. Okay, that's why our law was set up this direction in order to make a conclusion. Again, our given has to come from the if part or we can't make our conjecture. So this person got it wrong. This one was false.